So evals, I think, okay, so evals is the most important thing. In the consulting work that I do, people call me when their AI doesn't work. It's like, hey, like we've kind of prototyped something, we're excited about it, but it's like not really working. People don't know how to get unstuck. And so that's where this notion of evals comes in. You want a systematic way to test the efficacy of your system. It's really the only way you can build AI. So it's like integral to the building process of AI products.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am, of course, your host, Sam Charrington, and today I'm joined by Hamel Husain. Hamel is founder of Parlance Labs. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Hamel, welcome back to the pod.
Yeah, thanks for having me back. It's been a
It's
while.
great chatting.
You
It
haven't
has
aged
been
at
a
all.
while. Likewise. About 2-3 years, end of
Something like that,
21, I
yeah.
think, something
Yeah.
like that.
Yeah.
You were deep into ML ops. I think we spent a lot of time talking about that. We spent a lot of time talking about notebooks and literate programming and fast AI tooling and a bunch of interesting topics. But I wanted to get you back on the show because you've been quite prolific on LLMs and the way folks can take advantage of fine tuning and eval. Lots of interesting stuff I wanted to dig in with you.
Excellent.
So
Yeah.
looking forward to that. Were you at GitHub the last time we spoke?
Yeah. I think I was at
Possibly
GitHub. Yeah.
GitHub
I
or
was at
just leaving and you went to work with
Outer Bounds.
Outer Bounds for a bit. What have you been up to since?
Yeah. I decided to do, my own consulting company just because it's such an exciting time to be working with large language models. And it's a really exciting time to like see lots of different use cases with this kind of new technology. And work with lots of different companies. And so I've been advising lots of companies and helping them build AI products.
Awesome. Are there any use cases that jump out at you as novel, under the radar, without kind of divulging your client's, IP or anything like that? Like sometimes think that, yes, LLMs are very exciting, but a lot of the use cases are very similar. And I'm always looking out for kind of novel use cases where, it's like surprising that would actually work. Does anything jump out at you when you hear that?
I wouldn't say there's any novel or use cases that surprise me anymore. I think I have gotten over the stage of being surprised.
Okay.
Um, but I will say that the things that seem to work best are user interfaces that have humans in the loop in a very thoughtful way. So instead of just having, let's say, a chatbot, having some kind of interface that allows folks to interact more richly with the software. So, for example, one of my clients is this real estate CRM company called ReChat, and they have a chat interface. However, whenever you interact with the chat interface, it pulls up different widgets. So, if you try to search for a listing, in the chat interface, it'll pull up sort of a listing. You say, okay, I want to find properties that are, greater than 2 million or less than $2 million with such and such in the zip code or whatever your search is. It'll pull up a little widget with the results that you can refine. So it actually brings the user interface to it's a very thoughtful sort of interaction between the software and a human rather than this like naive, let's just push the chat interface, to the user. And so like things like that make a lot of sense because it allows people to work with AI when they should be working with AI and not work with AI when it doesn't make sense to work with AI. And like kind of inject the AI in the workflow in a very thoughtful way. And it takes a lot of work to do that. from a design perspective, a lot of people just want Chat GPT for their software,
Right.
but that's kind of the lazy thing to do. The thing that takes a lot more work is like, hey, let me thoughtfully figure out how to integrate it into the user's workflow. So wherever
Yeah, I
that
appreciate that.
happens, yeah.
I, I really appreciate that take. I see as well vendors trying to rebrand everything as agents, and I don't necessarily want to be forced into a dialogue box every time I want to interact with a piece of software. Like, we spent a long time refining the user experience for different types of software, and it all doesn't look, the same way. And I'd hate to think that we have to throw all that away in order to incorporate the intelligence that we can get from an LLM. What you're describing reminds me of I read some blog posts a while ago that coined this as generative UI, that was trying to, like, to some degree, dynamically um, kind of push UI elements into a chat framework. Have you seen that kind of take root more broadly among the folks that you're working with?
Yeah, and what I suspect is like there's many purposes of this kind of UX. It's like one is okay, obviously to help people do their work a lot faster, but also like to educate the user so that you want to use the same UI elements throughout your product. For
Hmm.
example,
Hmm.
so when someone sees a listing finder, they know when next time they see a listing finder in another place, even without AI, they know how to use it because they already seen it before. They kind of been walked through it, and people can choose to like do whatever they want. Like sometimes you don't need AI. Sometimes you just want to look around or whatever. So like it's an important like onboarding thing. Um, and so there's some deep kind of design thinking that I think needs to be done on a lot of these AI products.
The thing that I wanted to really dig into with you, or at least a really good starting place, is fine tuning. You recently ran what I think you initially intended to be a course on fine tuning, and it turned into a virtual conference with a ton of speakers, and looked like a lot of really interesting and good information. But that course, I think, grew out of your belief that people think of fine tuning as this thing that's like really complex and hard to do and get right, but it actually doesn't necessarily need to be all that complex. Is that right?
No, it doesn't need to be complex. And so the thing that I really like about LLM fine tuning is that it's very easy from like the mechanics of it. It's actually easy to actually apply the fine tuning itself. So unlike other kinds of deep learning that has come before it, where you kind of have to fiddle a lot with hyperparameters and architectures and stuff like that, when you narrow it down to large language models, there's a like really good tooling, and like it's also fairly easy to fine tune from a machine learning perspective. Like especially if you're doing something like a LoRA, it's kind of hard to screw up the fine tuning. You kind of have to try to screw it up. If you can,
I
just to
think that's
draw an
probably going to
analogy.
be surprising for a lot of folks. But before we dig into the details there, we probably should take a step back and, like, answer, the bigger question, which is like, when should you be thinking about fine tuning? Because I think, at some point the narrative was like, everyone wanted to fine tune, and, like, the people in the know were like, don't do it. Like,
No, for sure. Yeah.
99.99%, unless you're Google or Facebook or whatever, you probably shouldn't be fine tuning. And, you're saying now it's easy, it's not
Well, it's
as
easy. Like part of it is easy. I
part of
wouldn't
it
say the
is
whole thing. Yeah, I
okay.
wouldn't
So
say the whole thing is easy.
part of
Yeah.
it is easy, so I think it still leaves this space of, like, does that mean everyone should be doing it now, or, like, who should be doing it and when? And also, what should the expectation be, when you fine tune, versus use other techniques? Like, what is fine tuning really getting you? So really, I'm wanting to, like, take a step back and introspect your, thinking about fine tuning and its role in place?
So most people probably shouldn't fine tune, especially when you're starting out. You should try to use a model off the shelf. If you can, use OpenAI, use Anthropic, and start building stuff. You don't want to get nerd sniped by this whole exercise of fine tuning, because like you need to like have a reason to fine tune, and like you need to have some failure mode that you are experiencing that necessitates fine tuning. When do you fine tune? Okay, there's many different answers for this. So one answer is you want your own model of some kind, and that model is usually an open weights model. Let's say Llama, Mistral, whatever. And that open weights model off the shelf doesn't quite do what you want it to do, or it's not powerful enough, to accomplish whatever you want to do on your domain. And in the situation where you, so like, yeah, in that situation, maybe fine tuning could be the right fit for you, with the caveat of, fine tuning really shines when you have like really narrow use cases. Like we're trying to have a model do something very specific, or the LM do something very specific. If your LM is just a general purpose chatbot that can do anything for anybody, then that's not, fine tuning is going to be a lot more difficult, and it's going to be a lot harder to evaluate that. And so, I would say, okay, like, if you're like a narrow scoped problem that's doing a very specific thing, then fine tuning is more likely to work.
The canonical use case that comes up all the time with fine tuning is like text to SQL.
Exactly. That's the best. That's one of the best use cases. In fact, one of my clients is Honeycomb. Honeycomb has an observability platform, and they have a query language called HQL, a Honeycomb query language. So it's kind of like, it's not SQL, it's a domain specific language. So they have, a natural language to HQL sort of product, but that is such a narrow task that fine tuning works really well for that. So like there's a lot of dimensions to like when fine tuning would work for you. One is like maybe you want some kind of data privacy, you want your own private model, and you want to make that model a little bit better. And if you have like that narrow scope use case, okay, that might be like some sweet spot. Another reason why you might think about fine tuning also has to do with open weights models, is if you want to try to have a small model, like a very, very small, very cost effective model that you can deploy in your infrastructure in a flexible way. If it's like, maybe even if it's small enough, you can try to deploy it, on mobile devices and things like that. So that's another reason where you might consider fine tuning, is like, especially with those like smaller models, you might want to try to specialize them to get them to do really well on that task, to kind of, you know, raise their performance level to try to approach the ones of the bigger models that are not fine tuned on your domain. But there's a trade off. Like fine tuning isn't free, even though fine tuning is easy from the perspective of like there's a lot of tools out there. I mean, you can even, fine tune OpenAI um, with their API, which is a really straightforward process to go through. Once you start fine tuning, now you have to manage that whole process. There's a whole process that you have to think about of continuously training that model, evaluating that model for the purposes of fine tuning, curating data, um, debugging things. And once you kind of commit to fine tuning, also like you sort of start to specialize your model a bit on that domain data. So like you have to constantly sort of manage that, because as your product is evolving and you know changing over time, you have to co-evolve your fine tuning with that. So it's not free. It's actually can become very expensive in that sense. So that's why the narrow use cases mitigate that. Like if you have a really narrow use case, then like okay, if it's not, especially if it's stable, it's not changing that much. Like the honeycomb query example, it's like okay, honeycomb query language is not really changing at all, and if they want to tweak it over time, it'll be like some incremental tweaks. It's not like this insanely shifting product. Whereas like okay, if you want a general purpose chatbot to do anything on Salesforce,
Mhm.
then I don't know because just maybe Salesforce is like changing and adding new things constantly. It's a really big surface area and like all this stuff. So that's kind of some things to think about. Of course, you can try
You
to
you
tackle
mentioned
that
something in
problem.
there about powerful enough, and even this idea of using a smaller model that without fine tuning wouldn't have the capability that you need. What should expectations there be? Like, does fine tuning allow you to take a 3 billion parameter model and get, GPT 4.0 level performance? Like, how should someone think about what you mean when you say make a smaller model more capable?
Yeah. So you can think of it like this, like the honeycomb example, we're going from natural language to honeycomb query. You can almost think of it as like that's almost trivial for GPT-4 in a way. That's GPT-4 is like kind of maybe overkill for that in one sense. That's like one side of the equation. And then another side of the equation is like, hey, it's a very, very, very scoped task. And so you might not need all of this like reasoning capability. And so you can raise the bar. So in this situation, we were able to like fine tune a 7 billion parameter model to outperform like GPT 3.5. We didn't benchmark against GPT-4, but it's pretty good. And so that's a big win. If now, for example, they can offer that to their enterprise clients, and they don't have to go through this like complicated data privacy situation and like SOC 2 compliance and all this stuff where you have to like shift data around and all that. So you can um, approach the quality of bigger models, but you have to keep in mind of this like narrow tasks thing. And so a lot of people don't realize like the narrow task thing is a big sort of elephant in the room because
Yeah.
people are not
It's
good
not
at
like,
scoping narrow tasks.
right, right. It's not like, you know, you have this list of potential use cases for fine tuning that is narrow domain, or you want a smaller model, or you want privacy. Narrow domain is kind of a precondition that you need to meet in order to, like, if you don't have a narrow domain, then you're probably going to have a problem, even if you just want a smaller model. Like, is that
So there's a
fair?
spectrum. Yeah, there's a spectrum. So I'm talking about like most people when I say this, I'm like generalizing and saying like, hey, like you should have a narrow domain. Um, that's a sweet spot. Like when you have a narrow domain and you want data privacy, um, and you want a smaller model and you want the freedom to like, use it wherever, then you have like lots of reasons to do fine tuning. You have lots of reasons. And like one reason may not be defensible enough depending on what happens. Like if it's just data privacy, you're like, oh, like I don't trust OpenAI. It might become a day where you do trust OpenAI. So like, you know, now there's a spectrum between like fine tuning and continued pre-training, you know. So
Yeah,
there
elaborate on
are
that.
yeah, there
I, I,
are
th- I think they're
models
used interchangeably quite a lot.
kind of. Yeah, so the idea is like they're really like okay, pre-training and fine-tuning are really the same procedure. Like you're continue the training process with more data. The idea of like continued pre-training is in addition to like domain specific data, you like mix in this more generalized data like from the web and so on and so forth. The idea being you don't want the model to lose its like general capabilities. You don't want it to over specialize in your domain.
Okay.
You want to like retain those skills. Don't want to get rusty just, on those things.
Got it. Okay.
And so there's some like really competitive fine tunes out there that people have done exactly this. And organizations like News Research have put out a lot of fine tunes like this, where they've trained on lots of different kinds of heterogeneous data sets from different domains, like at the same time. Like they mixed it together and they've curated the data sets. They cleaned them up to like raise the performance generally of these models on against a battery of different benchmarks. So that is a thing. And you maybe want to do that, but from a commercial perspective, I would say for the most part, you want to fine tune on a narrow task.
I think it's maybe important to highlight what you just said from the lens of, let's say you've checked all the boxes in terms of, your use cases and the applicability for using fine tuning. I think the conventional thinking is you use an off-the-shelf model that someone provides you, or you fine-tune it yourself. But you also kind of highlighted the idea that there are other people that are out there publishing fine-tuned models. And so if you can find one of those that meets your needs, you might not have to do the fine-tuning yourself.
Yeah. So I would say like one, try to not do work yourself wherever possible. I think that is like a good principle in life. It's like one, use OpenAI if you can, use Anthropic if you can, and go as far as you can with prompting. You know, like don't fine tune and try to do things like including examples in the prompt. So that's referred to as few shot prompting. There's also like a little bit more advanced techniques like dynamically including examples in the prompt that are
Hmm.
related to the user input. So it's kind of like if you think about RAG, but
Rag
for
style.
examples,
Hmm.
things like that. Like try to push that as far as you can before going to fine tuning. And then also, even if you do need to go with an open weights model, try to find an open weights model that's already fine tuned on that domain. And then you might want to just start from, and if you do want to fine tune, maybe you start with those models, like the one that is as close to your domain as possible. You just maybe get a bit of a head start instead of going from just starting from the blank slate or starting from like the base model.
And are you just looking on Hugging Face for those models, or is there some other repository that people are
Yeah, looking
using
on
the?
Hugging Face and like roughly bookmarking things on Twitter and hoping that I remember. You know, there's a leaderboard. There's some leaderboards. You have to take all these leaderboards with a grain of salt, because benchmarks are kind of noisy and people, there's a lot of data leakage from the benchmarks into the training. Um, so you have to kind of ask around and dig into it to see like what you can trust. You kind of have to use it yourself also. Um, but yeah, it's like starting from there. And I would say like in a shrinking number of cases, it is the case that, as models get much better, um, like the business case for fine tuning keeps like shrinking more and more, but it's still there. Like uh, it's still there. And, you know, you can, it doesn't need to be complicated. So, in the easiest way to fine tune is like use OpenAI. You can fine tune OpenAI models. Um,
And you're essentially just giving it a list of examples there.
yeah, you just give it a list of examples and you can start there. It's a good way to try it, at least like get a sense. And, you can kind of iterate from there and see kind of what works for you. Um, but it is really fun, and beyond fun, it is like very valuable to a business if you can, eh, you know, when you have, it's a slam dunk when you have a small model, a narrow use case, and that small model really knocks it out of the park, and you can just hand it to a company. It's like this is your model, and they can just deploy it. That can often unlock lots of value. So it's like, it's kind of like a spectrum. It's not like a good, let's say, flow chart I have, but it's kind of like as many, when you start to stack up all of these reasons, yeah, the more you have, then the more it kind of tilts in favor of fine tuning. But yeah, the data privacy one, I suspect. I mean, in the early days of cloud, people were very suspect of putting their data on the cloud, and now no one really bats an eye on, like, uh, about the cloud. I suspect the same thing might happen with large language models. So I don't know if the data privacy concern is going to, you know, endure, but certainly the other ones might. Um, and so yeah, we'll see.
Mhm. So you figured out your kind of business case for doing fine tuning, and now Hamel's here to tell you it's not as hard as you were told. What does that process look like? What is the first thing that you need to do when you are committed to going down that path and you're, past the doing it via an API level?
Yeah. So there's some really good tools out there for that help you fine tune. My favorite tool in sort of open source land is Axolotl, and I really like
Axolotl?
Axel. Yeah, it's called Axolotl, um, and it's made by this guy Wing Lian, pretty cool guy. He so basically what it is, it's like these config files. And I hate config. I normally really, really hate config driven development. Like I hate anything that is like you fill out a config file and then that's how you program. Like there's nothing I hate more except for this. Like I hate
Except for
everything that's like
Axolotl.
this. Yeah. Like I hate
Okay.
Kubernetes. I hate GitHub Actions, like all that stuff. I just want to throw it out the window. But like um it's a very useful feature for kind of this like fine tuning large language models, because these config files, like they kind of like traded in the community. They're like, oh, how did you train whatever, like Mistral 7B on this data set to get that outcome? They're like, oh, let me send you my config file. That's all you need to know. Like,
And what's the scope of the config file?
yeah. So the config file has what the data set is that you're going to be fine tuning over. A lot of times you might be referencing a data set that's on Hugging Face, but it can be a local data set. It'll tell you what the prompt template is. So that's like a really huge thing. Like the prompt template is like it's like the thing you have to like really worry about that in terms of like string formatting, how you format it. Is it compatible with the base model? If your base model has already been, fine tuned with a template, you want to kind of preserve that as you keep tuning.
And just to take a step back, well, a couple of interjections. The first is if you can't find Axolotl, we will put a link into the show notes page so that you can just click it and find Axolotl. But um, to take a step back, like in terms of the prompt template, and fine tuning. You're fine tuning, on your data. So presumably you've got some, you know, data set of examples that you want that are representative of where you want to improve the model.
Yeah.
And, are those typically and this is kind of getting to the prompt template, are they typically in like a question and answer format, or is it better to keep them more neutral so that you can then impose a prompt template? Like what should
Yeah.
the data set look like?
So the data set needs to look exactly like what is going to happen in production. So if a user is asking questions, then it needs to look like questions and answers. If it's going to be multi-turn conversations, then it needs to be multi-turn conversations. If it's going to be text to SQL, it needs to be just text to SQL. Um, and it needs to match exactly what's going to happen at inference time. So whatever the prompt template is, if it's like, you know, if you have some like bespoke prompt templating syntax, like angle bracket Sam forward slash at the beginning of every message, then you have to make sure that that is the exact same kind of templating you use at inference time. And that I see is like a really big foot gun. A lot of people, that is the thing that is the nightmare of everyone doing this.
Meaning they think they've collected, this
Yeah, they're
very
like they
valuable
think the
data
prompt
set
template is
and
X, but it's really Y, and like,
oh,
oh, why
okay.
doesn't it work? Oh, because
Uh-huh.
I left out a space here. I left out this colon here in this like place.
Okay.
Because like the model was trained with one. It's like, oh, like I'm pretty sure the model was trained with like prompt template X, but then when I go to inference it, I'm like using a different one, and it's like, well, why isn't it working? And so there's many such cases of like, yeah, I'm missing a space or
Mhm.
whatever, and
And
sometimes
is
it
the
can
prompt
really throw
template,
it off.
like, is it abstracted from the way you've collected the examples? Is it like a is the idea that, it's at a higher level than the examples
Yeah, that's a
themselves?
good question. So like the prompt template is just like, you know, so it's all a string at the end of the day that you feed into. It's all a string. The string gets tokenized. And so the question is like, how is the string constructed before it gets tokenized? And so when the user asks a question, they're not saying like, they don't have like, you know, they don't type in, this is the question section and then put their question. They're just typing the question. That should be the right user interface. But then when you send it to the large language model, you need to put like, you need to give it some idea of what the hell is going on. Kind of like a human. I don't want to anthropomorphize things too much, but you want to say, hey, like, you want to give the language model some instructions, like in the QA. In the QA example, you want to say, hey, there's going to be a question, and the question is going to be inside question tags. And then I want you to produce an answer inside answer tags. And so you put some guidelines that help the language model understand what the hell it is in this blob of all these strings, like what is going on, like what is the question, what is the answer, what is the function call,
Mhm.
what is the function call result.
And all that
Um,
formatting then is your prompt template, which is different from your examples, or kept separate for, the convenience of reformatting, typically your from the
I
examples
see. Yeah.
themselves.
A lot of times it's kept separate. Yeah. Then Axolotl is kept separate, and you can choose which one to apply. You like kind of, you say, okay, I want like the chat ML format, or I want the alpaca format, or whatever. And, those are different, whatever templates. Um, which one to use is kind of up to you. Like different templates have better support, or they have like, some templates are like too very simple, like they don't even have like sections for certain things. They might not have, you know yeah, they might not do a good job of like multi-turn conversations. They don't have an affordance in the templating specification, so you kind of like have to make one up, and then you might decide, you know what, I'm just going to use like a different template that actually like has thought about multi-turn conversation, stuff like that. um you know, when I'm fine tuning, so like just to give you some insight, because when I fine tune, I'm doing it for these very narrow use cases. Usually, I don't like to use a model that has any templating at all. Or I just do my own templating, like little bit of templating or like zero templating. Because I'm usually going from like text directly to something. Um, so yeah, I like to start with base models and not instruction tune models. Instruction tune models are already is like, instruction tune just means you're trained a model to, have question and answer, which implies that there's a chat template or there's a prompt template that you have to worry about. So I just don't want to deal with that mess. I just try to use the base model and just come up with my own like simplified template that's specific to the domain.
And is the is that true even if the domain is chat or conversation? Like, is
Yeah,
it, you know,
if
that
the domain is chat or conversation, it's helpful to have a template. I mean, it's helpful to like think about it. And like, yeah, sometimes you want to just keep training on the instruction tune model. But I try not to. So, okay, for, so chatbots, um, in a lot of situations, it's, it's a usually like not narrow. It's like a core, like, there's this. when you put a chatbot in front of a user, you have to work really hard to scope it. There's just like an inherent user expectation, like, oh, this is like magic AI chat GPT. And so usually what ends up happening is at least when I'm involved, is I say, okay, like let's not do that. Like let's kind of, pick a more narrow use case to do fine tuning. I will say though, like I have fine tuned models like that before, and it's totally fine. But I would just say for the most part, yeah, like I don't usually not fine tuning for chat, usually fine tuning for like a very specific purpose of like
Got it.
doing some kind of data transformation or extraction or something like that.
Okay. I think we were talking about like what is in the Axolotl config.
Oh yeah, so it's just like it's your data, it's sort of like the prompt template, and it's all these like hyperparameters like batch size, learning rate schedule, all that stuff. And what's useful about it is there's like a
That sounds like
whole
all the hard stuff from deep learning
yeah.
that you just said we
Yeah,
didn't
so
need
it's
to
like
worry about anymore.
you don't have to worry about, because you can just say, okay, if you want to train whatever some model, you can just like look at the config that everyone
Ah,
is
because you're
using.
not building the config from scratch. You're
No, you're
just
definitely not building
getting the
from scratch.
config. Okay, got it.
Yeah. Yeah, that's the magic part. You don't have to worry about all this like fiddly crazy stuff. You're just like, okay, look, I'm gonna copy and paste this config. May not even understand
And
like half the things in the config.
the
Yeah.
presumption then is that um, those types of hyperparameters are not, you know, deeply sensitive to, the distribution of my particular data. It's more maybe correlated to the model that you're fine tuning.
That's a good question. I think
Because
it
otherwise, I've
yeah.
got the
Yeah.
hyperparameter problem.
So okay, like it can be sensitive, but
Okay.
it's not, especially when you're fine tuning like a LoRA, which is in a lot of case people are these like adapters. It's not incredibly sensitive. It's kind of like if you remember Random Forest, how it was like kind of hard to screw it up. You just like
Yeah.
pointed at your data and it kind of felt like it was working.
Yeah.
Sure, there was some hyperparameters, but generally people are like, oh yeah, this is like very easy, like just call dot fit and it's like working. And like, it
Hmm.
was less fiddly than deep learning,
Yeah.
like for sure, like
Got it.
100%. Is the same feeling now with training large language models. Is very like it just works. Like you get something that at least you get something that seems to work. And then you can always make it better, of course, by like, you know, kind of varying these hyperparameters, but you're not like, oh, it doesn't work at all. Like I'm just lost. Like what the hell, kind of it, it's not like that. And like starting with a known config is a great starting point.
We're on this journey. You've decided that you're going to fine tune. You found Axolotl via this podcast or wherever you found Axolotl. You've got your config file. Are those config files just in the Axolotl Git
Yeah, they're in the
repo, or do you have to
repo.
go find
Yeah, they're in
something?
the
Okay.
repo. They're in like an examples folder. Yeah.
So you've got the config files from the repo. Like, do you need to like deeply understand LoRA, have done the math, have read the paper, or is
No,
it just a kind of infrastructure that you don't have to think about?
no, you don't have to do it. You don't have to think about it. What you do have to worry about is like installing Axolotl, dealing with CUDA errors and all that stuff. So, um, you
Because you
might,
said you wanted to run it yourself. So
yeah, you said
you
you want to
inherit
run
all
it
those
yourself.
problems.
So, like, yeah, so you're gonna have that problem is not gone anywhere. Um, there's a Docker container, so you can use that,
Okay.
and that seems to be fairly
If you can
stable.
get it to find your
But you
GPUs.
know how it is. Like, I can say, yeah, it's gonna be okay, but like, I mean, that's not. I would be lying if I told you that. So yeah, you can just you can use it to fine tune a model on your data. So I mean, like, where's the thing that we're waving our hands over in this whole conversation is like, oh yeah, like you have your data. And like
Right.
we shouldn't wave our hands over that. It's like people have been waving their hands over that for ever since data scientists were coined um, as a profession. And the thing that's really interesting is if you already if you start with not fine tuning, like if you're using OpenAI or whatever, and
And you
you already
instrument it.
you instrument it a bit,
Hopefully, yeah.
then that can become your source of data, which is really
Mhm.
fun. So like you
I guess
have
the
to have a
question
way
is, like,
of
how many examples do you need to effectively fine tune?
yeah.
How dependent is that on your use case?
Yeah, I mean, so honestly, I don't have the answer to this of like how what's the minimum number. It doesn't feel like it's that much. Um, I just kind of get as many as I can within like the time budget I have in the compute budget I have. So like, you have to make sure. Okay, like so you have to make sure you're instrumenting your system, so you're capturing all of this large language model invocations. Yeah, and then you have to have a way of like curating and filtering that data. You don't want to have you're gonna waste a lot of compute if you have like bad garbage data that used to train your model. But once you curate that, yeah, I can get really good like really good results in like 1,000 examples. And a lot of times, what you can do is you can even synthetically generate data based on examples. So so I've done that before. I've like expanded data significantly by using a very powerful model like GPT-4 to like expand my data set. Um, so yeah, there's a lot of tricks that you can do to generate that data and kind of bootstrap yourself into getting data, which is the key difference between classical machine learning is like, oh, I don't have data. I need to go label everything. So I guess we're stuck. There's like lots of ways to get unstuck.
You've mentioned LoRA a couple of times and positioned it as an option. Like, if you're going to fine tune and use LoRA, then, it becomes easier. Like, well, first of all, I'd love for you to like spend a few minutes talking about, LoRA and what it is, but also what is it an alternative to, or what are your other options when you're kind of filling out your config file?
Yeah. So it's basically, I think it stands for low rank adapters.
Low rank
And
adaptation or something like that?
yeah, something like that. It's basically like, so you're not doing a full fine tune of all the weights in your model. You're just fine tuning a very small, like this adapter. Um, and it just makes it a lot easier in many ways. It reduces the amount of GPU VRAM that you need, which makes it a lot more tractable on like consumer GPUs or other kinds of GPUs. Um, and it's also, yeah, it tends to, I guess, like some much like smoother loss surface is like it's it's not that as many parameters. Um, and it's a nice way to get started, at least in terms of like training these adapters. And actually, it can be fun to. There's a lot of tricks you can use with these adapters. So like these inference frameworks allow you to like load the base model and then hot swap adapters.
Hmm.
Um,
Okay.
so which is really cool because you don't have to incur the cost of loading an entire model. You just load the adapter for that forward pass and then go on your day. Um,
And that, incidentally, if I'm not mistaken, is a framework that folks like, Google and Amazon use to allow customers to fine tune their own models. They, are using LoRa, and they have, the customer is basically building their own adapter, and then they're like hot swapping the adapters out at inference time.
I have no idea. It's
It's my understanding.
yeah. I saw some advertisement of like Apple, what they're doing on device. It just seemed like from their explanation that they're doing something like that. Um, but I don't know exactly what they're doing, but it seems like very similar.
Mhm.
Yeah, so that's what it is. It's just a way to. It's like a parameter efficient kind of way to fine tune.
You mentioned inference frameworks. What are the inference frameworks that you
Yeah,
are thinking of, and what's their role?
yeah, VLM and NVIDIA. There's like the NVIDIA Triton. There's NVIDIA Triton, which is like the front end, the back end. They have like TensorRT LLM. Um, I like VLLM because it's like really easy to use and straightforward. It's like kind of a good trade off if you're not wanting to squeeze tremendous amount of performance out of your models, but um, have it's like a pretty easy to use framework for inference. So I would say those are the two that I kind of use. It's either the NVIDIA stack, the TRT, and the TRT LLM with some kind of inference server, or VLLM.
And what is like what specifically is it doing? Is it like I don't know, you remember Bento ML? Like is it analogous to this where you've got like an inference server
Yeah.
and
Okay. Yeah. Like, I
distribution and
just
load
kind of
balancing and
glossed
all
over
that
it.
kind of stuff? Or is it
No,
just
no. So
like
I
a
glossed over it too much. So okay,
okay,
sorry. So inference servers, a lot of time there's like a front end and a back end. And what does that mean? So like the back end will do things like model compilation. Um, so like quantization, model compilation, different kinds of optimization to the model to make it run faster. And then the
got it.
front end,
So
yeah.
meaning the you your model may be distributed as some weights, some set of weights in like a safe tensors format, but the inference process is probably going to be using some other form or artifact in memory, and the back end that you're referring to, the inference server, is going to get as close to that as can be cached and like start there at for an inference just for performance reasons. That's kind of what I'm hearing.
I have no idea exactly what is going on concretely. Like I don't deeply know what compilation does. I have some general idea, but I don't want to I just like actually treat it just like magic. I'm like, okay, this is gonna make my this is gonna make my model run faster. It's gonna so I'm just going to apply the
Okay.
steps
Fair
that they're
enough.
telling me to apply. Like, yeah, like there's
It says a
quantization,
lot
which
that
I
you can,
yeah.
do this for people like and not have to know those details. That it speaks to, I think, a level of maturity in the tool chain and like abstraction that wasn't here, a year or two ago, and probably was the reason why everyone said don't even bother trying to fine tune unless you're Facebook or Google, because you had to invent all this stuff yourself from the ground up.
Sure. I mean, it helps to know a little bit like, okay, it's helpful to know what quantization is so that when you do, and you want to measure everything. So it's okay to, like, generally speaking, you want to try stuff. There's a whole host of different options, and a lot of these inference servers and backends have lots of knobs, lots of hyperparameters that you can tune. And honestly, like anyone that I talk to in industry, like they don't understand all of it and they just try stuff. Like they try a lot of stuff, they fiddle with it. It really depends on like, you know, your like throughput versus latency requirements, like how to actually tune these things to do what you want them to do. And so the reason why like it's okay, why I'm okay with sort of treating some of it like magic is because like end up measuring it all,
Mm.
you know, and
Hmm.
then kind of reasoning about what's happening. It's helpful to be somewhat familiar with the terminology so you can kind of know like why certain things are happening.
Hmm.
But I would say like you don't need to be an expert in all of it to start using it. You can definitely measure things as well, and kind of like you don't need to like know all the ins and outs of like model compilation and exactly how it works.
Hmm.
You can do it and see like, okay, what's happening to my performance, latency, so on and so forth. So yeah, so and that part is not non-trivial. Like hosting your own model is actually non-trivial. There are a bunch of startups out there that will host your model, like Fireworks or Replicate, um, Modal, things like that. But yeah, you have to think about like those costs and how that makes sense given your scale. And so kind of that's why it goes back to this whole like in the beginning, Just use off the shelf model. Because those off the shelf models, like actually, they're very like attractive in their costs. Like they don't cost that much, especially at a small scale, and they have like
Right.
somewhat low latency, and they're available most of the time. And
Hmm.
so it's a great place to begin. It's actually very difficult to compete with that.
Hmm.
So yeah, I think I strayed far from what you're asking, but yeah, like inference, and I'm not an inference expert. There's people that came into the course that were like inference experts. And actually, this like whole debate about fine tuning had two guest speakers. One was Emmanuel Amundsen from Anthropic. The title of his talk was "Why Fine Tuning is Dead." And then there's another talk from Kyle Corbett, who is CEO of OpenPipe, and he was talking about. He was also saying like you should usually not fine tune, but he had some other perspective of like, okay, in these situations, um, you know, it is very extremely helpful to fine tune. And OpenPipe is a tool that helps you fine tune based on your logs. So based on how we were talking about collecting those logs
Hmm.
for fine tuning.
Hmm.
Um, so I would highly recommend watching both of those. Um, those are
Are the
like pretty vendor.
videos posted now, or do you
Yeah,
need
those are
to
on like
register for the
YouTube.
course?
No, you don't have to register. All this. So by the way, the whole course is going to be open. Is most of it is open. They're just
Okay.
we're processing the videos. You know how it is. It takes time to whatever. Uh, so yeah, I can give you the links for those, and you can put those in the show notes.
Okay. Awesome. Awesome. So the question one level up on the stack was, what were your alternatives in terms of LoRa versus? Was the answer to that VLLM and other inference servers? It like is or is that
No. So
I
like,
feel
oh,
like that's
sorry.
mixing up different levels of
No. So
abstraction.
like, you can do inference with LoRa. You can, it's like the adapters. You can also merge the adapter back into the model so that you no longer have an adapter, or you can choose to keep it separate. And the inference frameworks are all good about, okay, like if you have an adapter, let us know. But you can just. It used to be the case that like when it was earlier on, like not everyone had support for adapters in the inference side of things, so you kind of had to merge
Got
it.
it.
But now you don't. So
Are you typically choosing between LoRa and some other alternative when you're filling out your config file? And like, what are you thinking about as you're making that choice? Or,
yeah, so okay, I don't try to optimize it too much. Like, I try to start with the simplest thing first. So I usually try like LoRa and try to fine tune it on a consumer grade GPU or a workstation grade GPU, not a server grade, just to see what happens. And if it's good enough, if it's pretty good, I'll just call it a day and say like, okay, this is like really good. Not try to like hyper optimize things. You can do a full fine tune, but like, yeah, full fine tunes can give you better results. Um, but I've had really good luck with using those adapters. To be honest, this like
okay.
worked really well. So had to go. I haven't really had to do a full fine tune
And can you
on the
do
use
this
case I worked on.
reasonably on Apple Silicon, like just on your laptop?
Oh,
Or do
interesting.
you?
I haven't tried that. So I actually
I've
try to
been
keep my
pleasantly
life like
surprised
super
by
simple.
what
Yeah.
you can do now on Apple Silicon after years of just not having any GPU options
Yeah.
on a Mac.
I know that it's like people are inferencing models a lot on their Apple Silicon. I
Hmm.
haven't tried to fine tune. I know there's some frameworks out there, things like MLX or something that
Metal
maybe
or
allow
something,
you,
metal extensions, I think,
yeah,
something
something
like
like
that.
that.
Hmm.
Again, like there's too many things going
Just
on
a lot of moving parts.
that I just tried to simplify my workflow. I don't want to deal with that, you
Yeah.
know? So I
Yeah.
just try to remove like these variables that can complicate things for me. So I just stay on NVIDIA. Cause like, yeah, just like cleaning the data and like designing the application is hard as it is.
Hmm. And it sounds like another kind of linchpin in all this is evaluation and measurement, and so that you can in the case of this conversation, like feel good about all the things that you don't necessarily know, like the inner workings of, because
Yeah.
you know the
Yeah.
impact that they're having on your data and your model's performance. So, like, maybe let's segue into the way you think about evaluation measurement for LLM apps.
So evals, I think, okay, so evals is the most important thing. So like I think like when it comes to large language models, that's all I talk about nowadays because like in the consulting work that I do, so people call me when their AI doesn't work. It's like, hey, like we've kind of prototyped something. It um we're excited about it, but it's like not really working. It demos well, but it doesn't work like in the real world, or it's not work, there's a lot of failure modes and we don't know what to do.
It seems like a lot of the game right now is like, I can get a really nice demo, but how do I get it to production? And actually, I mean, we've been saying this for a really long time in ML and
Yeah.
AI.
Yeah, yeah, but it's especially the case in large language models because you can get to demo insanely fast, like within a day for sure. And so, um, but even like the very polished products, like okay, people don't know how to get unstuck. They're like, okay, I use like OpenAI. I've built like some interesting product around it. It solves a problem, but like the AI just like fails too much to do something or makes too many mistakes. And so the key, like and then like what people do to start off with is they do prompt engineering. Is they see a failure mode of something going wrong and they update the prompt. But then like really fast it becomes very unwieldy and you end up making a change to a prompt and it actually causes some other error. Um, and you kind of get stuck. And so that's where this notion of evals comes in is you want a systematic way to test the efficacy of your system so that you can make a change and you can see immediately like okay what did you fix your errors, did you create new ones, things like that. And it's like very analogous to software engineering in a way. Like you would never write software without unit tests. It would be very difficult beyond a certain point. It would be unsustainable. Same thing with large language models. Like you need some kind of tests. And it's really the only way you can build AI. So it's like integral to the building process of AI products. It's not even an optional step. The interesting thing is there's not too much information out there around how to do it. There's a lot of tools. So there's a lot of people. There's a lot of different startups and things like that. And the thing that trips people up is they focus a lot on the tools, but not the process of doing the thing. So the tool can help you a little bit in the sense like make the process easier, but if you don't have a good process on like how to think about evaluations and do the evaluations, then it's not going to help you. And so with evaluations, really, it's you know a process of looking at lots of data. First of all, removing all the friction you can in looking at data. So making sure that you have a way of looking at all these logs, these LLM logs, in a way that makes sense for you, like in a domain specific way. Um, then that allows you to look through the data really fast and navigate the data and also navigate it in a domain specific way that makes sense for your business. But then also, um, writing tests, different kinds of tests. So not going straight to LLM as a judge. So a lot of people when they think about evals, they're like, okay, one failure mode is they go to tools, and the tools have kind of this box of evals off the shelf. Like here's a toxicity eval, and here's
Right.
a conciseness eval, and here's a helpfulness eval. The
Mhm.
the problem is that all that stuff usually is not helpful for you and your use
It's too
case and what
generic.
what you yes, totally generic.
Hmm.
And um and so what you need to do is like write lots of different assertions, lots of other kinds of tests. So like you want to make sure that you write um as many assertions as you can before getting to LLM as a judge. And then when you do go to LLM as a judge, you need to make sure that that judge that you agree with it. So the problem with LLM as a judge is the question particularly becomes like, how do I trust it? How do I trust this AI to score my data or to do I know? And so you can apply like a systematic way to reason about that, which is like have a human also score or make a judgment about that data and then measure kind of like how much in agreement those two things are, and then try to align the judge over time, with the human. So like that's like in a broad sense kind of a process of like looking at data, writing tests, um, and doing that over and over again, and then making changes to your system. And that also ties into fine tuning, because if you that is the work. Also, if you do that properly, if you have if you have good instrumentation, good way of looking at data, good way of like labeling, curating data, and you have all of these tests that can that can also filter out bad data. You can curate data extremely fast, and you basically accomplish all the work of fine tuning. So it does tie into fine tuning, but it's more general than that. It's like even if you're not fine tuning at all, it's really the only way that you can systematically improve your AI. And you can almost like if you're not doing any evals at all, you can almost guarantee, or you can, pretty much guarantee that you can improve your AI by doing evals, because you have a way to test things and improve things. And there's like different techniques on how to improve things. But even things like, even things like uh, these automated prompt optimization frameworks
Like
that try
DSPY.
to, yeah, like DSPY, or, DSPY is probably the most kind of well known kind of tool in that genre. If you have really good tests and metrics, then that is going to, then you can actually do something with those prompt optimization things. If you don't really have a good handle on that and it's not really dialed in, then yeah, it's going to not be as great. So once you do evals, you unlock a whole host of things that are available to you. In addition to just helping you make progress, you unlock all these other tools, whether it's fine tuning, whether it's prompt optimization, or really anything else. Um, and yeah, so that's the thing that people struggle with. I would say a lot of people that pick up the phone and call me and they're struggling with their AI, you know, one of the first questions is like, "Hey, tell me a little bit about how you're testing your system, and tell me about what we're measuring." A lot of times there is nothing. A lot of times it's just, "Hey, you're just looking at it, like as a user." So yeah, I think it's the most important thing, um, at least at the moment, in terms of what is the bottleneck in terms of moving the community forward in AI.
Yeah. Yeah. Um, do you distinguish between kind of frameworks and tools when you think about testing? Meaning, you said, a lot of people kind of jump at the tools first and, get stuck behind what the tools offer. Is the alternative to that like building everything from the ground up from scratch, custom to your use
Yeah,
case, or are
yeah,
there
yeah.
some medium level frameworks that you can turn to help organize things?
So what I recommend people do is actually like try to use what you have first. So like use your existing unit testing framework, use, whatever CI that you have. Um, if you're gonna like log the results of your test, log the results in your test into whatever analytic system you have. It's not going to be great, but start there and do the process like 2 or 3 times. And then you have a good foundation in which to think about tools. The tools can
What's the
certainly help you.
process that you're doing 2 or 3 times? Like
Yeah, like is to like go through it to like write the test, observe like the results of the test, try
mhm.
to make your system better, try to, you know,
So bang your head against it a little bit until you feel
yeah,
like
like
you're
try
at
try
the
try to,
yeah.
make some progress on your
Mhm.
system. Like, oh, I have this error. Let me try to make it better. And then like fix the error, observe the error rate going down, validate that like, okay, you kind of have tests that make sense. And then it like will click in your head, like, oh, okay, this is a good way to think about my system. This is what I'm trying to measure. This is what's important to me. I need to look at this kind of data. This is the kind of failures that I even have. Um, this is a process, like who is going to look at the data, who is going to write the tests. Um, all of these different moving parts, like you kind of have an idea. And then when you approach a tool, you can actually use the tool. You can like appreciate the first, yeah, you can appreciate the tool and you can evaluate these different tools and like, for your domain. And then you're like more likely to be successful rather than, yeah, if you're just going straight to a tool, it's really hard for people to, they just do whatever the tool says on the front page of the documentation. They don't know. So, um, yeah, that's kind of what I would recommend. But there's different kinds of there's a open source tool. So there's something that JJ Allaire has been working on, but JJ Allaire is he created R
Cold
Studio,
fusion and all that stuff back
all
in the
kinds
day.
of all
Yeah.
kinds of crazy stuff. So he's recently created something called Inspect, which is a open source evaluation framework. So yeah, like he has one that's like open source. There's not too many open source things. There's another one called Open LLMetry.
Okay.
Um, but I think even Open LLMetry is vendor affiliated. So I think JJ's is the only one that I know of that's completely non-vendor affiliated. But then everything else is vendor stuff. So as I said, like first, yeah, let's like do it yourself based on the tools you already have. Maybe if you don't want to do vendor stuff for what some reason, maybe you're just by yourself and you're not like wanting to do. Yeah, you try out this open source thing, and then from there maybe try one of the vendors, or just skip the open source thing and go straight to a vendor if you want.
So the key insight is uh bang your head against a problem in your own words and in your own terms before you jump to some tool to define the problem for you, because you won't know what you're kind of missing in that loop until you do.
Yeah, absolutely. And it's not that bad. It's not hard as it seems. It's a good exercise to go through yourself. It's not like you're going to create all this technical debt or something by doing it once with the tools that you already have. There's a lot of people that just stick with that, by the way. They just like use the tools they already have and they like kind of like it. Um, but so it is good to to start there.
And do you find that it's obvious to folks what to measure, or um, to what degree is it use case specific versus kind of standard? Just by virtue of the fact that it's an LLM system.
Yeah. It's usually very all domain specific.
Okay.
Like when we look at the data, I think with enough coaching, um, 100% of people that I've come across have been able to learn how to do it very effectively. There's some skills involved in learning how to look at data and sift through it. Basically, teaching people to be very skeptical and saying like, "Hey, if something's broken, like let's be skeptical of the whole system. Let's look at your data very carefully." Um, a lot of times it takes pair programming and pair debugging, but I find that when people usually get it really fast. They're like, "Okay, you know what? It's kind of like it's kind of similar to the scientific method, you know? It's like a way of thinking. Like, hey, I need to prove to myself like why there's this like black box in a sense of this large language model. Don't necessarily understand like exactly how it's working, but you can run some experiments. You can measure some take some measurements and you can change some things. You can observe the changes to those measurements and you can think about that. And I think people kind like a lot of people have that inherent skill of thinking about that or like working that way. And it's like once it clicks in their mind, people are able to do it.
Yeah, maybe as a follow up to the question about kind of the domain specific nature of these measurements, like what are some concrete examples of like, a project and the important things to measure, that became apparent to measure in that project relative to, other types of projects?
Yeah. So, okay, like the real estate CRM example, the one I was talking about earlier, the company ReChat. So like their errors are quite boring in the sense like, okay, you have a UUID that's showing up in the output that's contained in the system prompt. And it's contained in the system prompt because it's trying you need it to use you need it for a function call later on. You might need it for a function call later on. For whatever reason, that UUID has been reproduced in the final output, and that's not good.
Hmm.
Or um, you know, certain sentences are being repeated twice. Or um in Rechat's case, because they're rendering these like UIs, these widgets, not just text, they have these special delimiters they're using to indicate uh like what the
Where to
metadata
insert
is.
the widget.
Yeah,
Hmm.
yeah, where to insert the widget. And things like, okay, is the delimiter, is there something wrong with the way the delimiter is placed? There's all kinds of assertions like that. Um and
And so at
so
one level, like
yeah.
there's query and response, and you can like probably want to be tracking everything at this query and response level, but it sounds like also um you're almost like featureizing that or applying assertions to that and coming up with flags that identify specific errors and storing that
Yeah.
information. Is that the
Yeah,
idea?
definitely. Yeah, the idea is like, and the reason I'm harping on assertion so much is a lot of times people think they can't write assertion. They're like, "Hey, it's fine. It's very subjective." And that is the case sometimes. But oftentimes I will look at data very closely and I'm like, I find kind of these patterns of failure modes that can be expressed as assertions.
Mm-hmm.
And it only comes to like looking at the data very carefully. And that's kind of the first line of defense. It's like, hey, you should try to solve all these dumb failure modes that you can test with assertions before moving on to things that are more subjective or require like higher level of reasoning. Then you have to go on to use like an LLM as a judge or something like that.
Interesting. Which kind
Um,
of goes back to the like bang your head against it. Like, well, collect the data and bang your head against it, because I'm imagining like you collect the data, you bang your head against it, and you'll start to identify these common patterns of things that can go wrong, and then you can both longitudinally track them. But if you know that anytime like a bad delimiter is appears in your response as bad, you can just like put up a guardrail against it in the application, so that you're not showing this bad thing to your users, or you're taking some action regenerating it, or if you can fix it manually or whatever. Like there's once you start
Absolutely.
to once you get the process down of like building a mental model around the things that go wrong, or expressing that in terms of assertions, there are lots of places that those assertions can manifest or be used.
That's a great point. And so this is like why evals are not really a separate thing. It's very much just part of building. And you can't build without it. And kind of as you evolve the testing, you don't want to, let's say, silo the assertions in your unit testing framework, for example. You want to keep it in some other location where you can both use it in your unit testing framework, but also you can use it in your LLM invocation pipeline. So you can do things like test for that and then do some self-healing, depending on how expensive that specific test is. So the assertion is cheap, so you can do it. Um, and so like all that stuff is, it kind of very much blends into the process of building the AI.
Hmm. Very cool.
Another example, like the honeycomb example, the text to
Hmm.
SQL. It's like not really text to SQL, text to that domain specific language. But the assertion there is like, is the query syntactically correct?
Yeah.
And not only syntactically correct, like in the abstract sense, but like, is it syntactically correct given the user schema and things like that? So that you push the assertion as far as you can go in a way that makes sense. Like in a naive, you could say, hey, is it a valid honeycomb query? Okay, that's one. But like if you think about it further, you say, okay, like let's think about the schema as well. And so it's always the first line of defense.
Hmm. Yeah, interesting. I came into the conversation thinking that like the conversation around if evals would be like very, I don't know, like maybe dialogue centric or RAG centric or precision recall, that kind of stuff, which comes up in a lot of conversations around RAG. But this is a much more of like a software engineering.
Yeah. I mean, you do want to measure the various components of your system, like RAG, and you definitely want to measure retrieval. Like actually, RAG is a fantastic place to apply evaluations because it's a very mature. Like retrieval is a very mature field, especially information retrieval. So you can apply a lot of the tools that we've learned over the last few decades to RAG in terms of um, the ability your ability to like retrieve the right information. There's a lot of metrics, there's a lot of science out there around like in tools, um but even before you go there, it's good to have these like more simple kind of holistic evaluations of your system, and then you can start to like measure these different components and stuff like that.
Awesome. Awesome.
I think that's probably the most important thing, is to like look at your data, and is really to look at your data. It's easier said than done. We've been saying that. You've probably been hearing that in your podcast for like, as long as the podcast has been alive. Um, it's very easy to say no one does it. Is why I have a consulting business, is because no one's looking at their data. If people start looking at their data, then I could do something else, but they're not. And I think it's a little bit cheeky because there is some skill involved, actually, that we can take for granted as data scientists. Like, there's a skill in like how to sift through your data really fast, having a nose for what's wrong, how to like kind of analyze your data or like look through it with the lens of the machine learning system, and kind of intuiting like why something might be happening. So it's like it's funny for me to say like, hey, look at your data, but there's a lot there. Um, but starting to practice it is very critical to this whole building AI stuff.
It makes me relate back to a comment that you made earlier in the context of fine tuning. Like we're far from like the hard days of training deep learning models. And, even before that was like old school data science, but like you're kind of pointing to this idea that it's, either it's a cycle or it's all connected or it's all the same thing. Like it's all about looking at your data and understanding how to intuit your way around the relationship between data and some objective that you have.
Yeah, definitely.
Yeah. Very cool. Well, Hamel, thanks so much for jumping on and sharing a bit about what you've been learning and seeing with regard to eval and fine tuning and building systems around LLMs. It's great
Yeah, thank
to
you.
speak and catch up.
Yeah, thank you.